All right, so we're on problem 6 now. They want us to find the difference quotient for f of x equals 5x minus 1 by computing the difference quotient. So the difference quotient is just a formula, f of x plus h minus f of x all over h. Okay, so I'm going to start by using that formula, and then now everywhere I see an x in f, there's only one x showing, I need to replace that with x plus h. Okay, so I have 5 times x plus h minus 1, then minus f of x. Okay, minus 5x minus 1 all over h. Now I want parentheses around the 5x minus 1 because the next thing I'll have to do is distribute the negative into these two terms here. Also, let's distribute the 5 into these two terms up here. So I got 5x plus 5h minus 1 minus 5x plus 1 all over h. Okay, and then I'll have some things canceling. So there's 5x minus 5x, those are gone. Negative 1 plus 1, those are gone. Okay, and that leaves me with 5h divided by h. The h's cancel. So you get 5 is the answer. Okay. By the way, the difference quotient of a line, that's what I got, is always going to be the slope of the line. That will always happen. So if I had, some other function, like let's say f of x equals negative 6x plus 3, the difference quotient would be negative 6. Okay? That will always happen. So the difference quotient is a way to describe how to get from one point to the next on a curve. So if you have a line, you just use the slope of the line. Okay, so I'd always get the slope if I find the difference quotient of a line. So, problem 7 would be, probably a better problem here. They want us to find the difference quotient of f of x equal x squared plus 7 by computing f of x plus h minus f of x all over h. Okay, so wherever I see an x in f, there's only one x showing. I need to replace that with x plus h. And I got x plus h squared plus 7 minus f of x. So minus x squared plus 7, you're subtracting the whole thing. So be sure to have parentheses around that expression because you're going to need to distribute the negative into these two terms next. And this is all over h. Okay. X plus h squared, the same as x plus h times another x plus h. So you got x squared plus 2xh plus h squared plus 7 minus x squared minus 7 all over h. And again, you'll have some things canceling. By the way, anytime I have a polynomial, I'm always going to have some things canceling up top. Anything not involving h will be gone. That will always happen. So here's x squared minus x squared, those are gone. 7 minus 7, those are gone. And notice how I only have terms involving h up top. So I got 2xh plus h squared over h. And h is in common with those two terms up top, so let's go ahead and factor that out. I can cancel it with the one down under. And that gives me 2x plus h, which would be the answer. Okay, that'd be as simplified as I can get it. Okay, so the difference quotient is a way to describe how to get from one point to the next on a curve. So here I don't have a line. How do I get from one point to the next on this curve? Like suppose that I go from x equals 1 to x equals 3. H would be the distance away from 1. So h would be 2 in that case. X is 1. Okay, 2 times 1 is 2, plus 2, that'd be 4. So I'd have to draw a line going from x equal 1 to x equal 3, and that line that I would draw would have a slope of 4. Okay, and that's how I get from x equal 1 to x equal 3. Or that'd be one way to describe to somebody how to get from that one point to the next point there. Okay. Problem 8 we want to use synthetic division or long division to compute this division problem. And you're going to write your answer in the form dividend over divisor equals the quotient plus the remainder over the divisor. Okay, I've shown this two different ways. So here's the long division process, and here's using synthetic division. Okay, so if I use long division, the expression that's in the denominator is always going to go outside the division bar, and the expression that's in the numerator is always going to go underneath the division bar. So now we're all set up to divide. Okay, and I'm thinking of an expression such that when I multiply it by x minus 3, the leading term is 4x cubed. If I take 4x squared and multiply that by x plus 3, I get 4x cubed minus 12x squared. I'm supposed to subtract those expressions. By the way, that's a common mistake in these division problems, is that students will be adding those. Don't ever do that, because then you'll be led to a wrong answer. You're subtracting everything. 4x cubed minus 4x cubed, that's 0. Here's a negative 14x squared plus 12x squared is negative 2x squared. Okay, and then I can bring down these next two terms. So I got negative 2x squared plus 5x plus 11. And I can divide again. If I tack on a minus 2x, so I'm thinking of a term such that when I multiply it by x minus 3, the leading term gives me negative 2x squared. So if I take negative 2x and multiply that by x minus 3, I get negative 2x squared plus 6x. Okay, and I'm subtracting those expressions. So just switch all the signs, or what I do is I just throw a negative in front of the entire expression there. So I get negative 2x cubed plus 2x cubed, that's 0. Here's 5x minus 6x, that's negative x. And then 11 minus 0 is 11. Okay, and I can divide one more time, it looks like. So if I tack on a minus 1, negative 1 times x minus 3 is negative x plus 3. I'm subtracting those. So negative x plus x, that's 0. 11 minus 3, that's 8. Okay? So then the leftover would be a fraction that I'm going to add to the quotient. Okay, the complete leftover information would be 8 divided by x minus 3. You're always going to divide by the expression that's out here. Okay, and so this would be my answer. I got 4x squared minus 2x minus 1 plus 8 over x minus 3. Okay, now let me show you how to get that same result by using the synthetic division process. Synthetic division is arguably a faster way to divide a polynomial by a binomial. A binomial is a polynomial, but it only has two terms on it. Okay? Now, you can only use synthetic division if you're dividing by a binomial. So if I have something that's more than two terms or only one term, I cannot use synthetic division. Okay, so to me, it actually is important that we know synthetic division here and long division, which is right here. Okay, so here's how we use synthetic division. I want the 0 of the denominator going in the upper left-hand corner here. So that'd be 3, right? 3 creates 0 in the denominator. 3 minus 3 is 0. So 3 is going to go in the upper left-hand corner of this, chart that I'm going to make. And then I'm going to pick off the coefficients in front of the each term in the numerator. So I have a 4 in front of x cubed, a negative 14 in front of x squared, a 5 in front of x, and then an 11 at the end. Okay, and I'm all set up to use the synthetic division process. So what I do is I bring the 4 down and then multiply it. 4 times 3, that's 12. Put that underneath the negative 14 there. And then add column 2. Negative 14 plus 12 is negative 2. and then multiply negative 2 by 3. That gives us negative 6. And put the negative 6 underneath the 5, and then add column 3. 5 plus negative 6, that's negative 1. Okay, and then take negative 1 and multiply that by 3, you get negative 3. And then add the last column there. 11 plus negative 3, that's 8. Now, you might see a line by the last number. You can have that or not, it doesn't matter. Okay, the last number is going to be my remainder. So, as an expression involving x, like when we divide this, we get 4x squared minus 2x minus 1 plus, now 8 is the remainder. The complete leftover information would be a fraction that I'm going to add to the quotient. This is the quotient, 4x squared minus 2x minus 1. The complete leftover information would be 8 divided by x minus 3. Okay, so that'd be the answer. Now, we already knew that, right? We already knew that because that's what we're getting over here when we're using long division. So it's not going to matter, you know, for this problem, if we use long division or synthetic division, the answer is the same, okay? Synthetic division is a quicker process, though, because I'm not writing an x out each time, right? Like, I'm only working with the coefficients. Okay, so that's why, you know, we'd say that synthetic division is going to be, you know, getting us the same result, but using a faster method, though. Okay. Again, make sure that you know both long division here and synthetic division here. Okay, you can only use synthetic division if you're dividing by a binomial. Something with 2 terms. So if I'm dividing by something with 3 terms or more, or you know, less than 2 terms, then my only option is to use the long division process. Okay, synthetic division is not an option there. Okay. There's going to be more times where we're going to be using synthetic division in these problems. So so you want to know that. Okay. And I'm using that in the next problem there. But why don't we go ahead and stop the video right here, and I'll pick up with problem number 9 in the next video there.